Welcome to Subnetting Level 10, Locating the Subnet. We can define a local area network, or LAN, as a group of host devices, such as computers, laptops, servers, or printers, that have a common subnet mask, a common default gateway, and a unique IP address within a defined range of IP addresses. We sometimes use multiple words that mean the same thing. So one example is that we have the word network. So there are different terms that are often used to mean network. So we might call a LAN a network. We may also call it a subnet. We might call it a subnetwork, or we could also call it a broadcast domain. So I want you to realize that when you hear these terms, we're just talking about one LAN. So a network, subnet, subnetwork, or broadcast domain is really talking about a LAN. We know that a network, subnetwork, or broadcast domain can also be defined by an IP address range. Let's take a look at the IP address range 172.16.38.24. The /24 defines the network. It means that the network has a total of 256 IP addresses and 254 usable IP addresses, where the .0 address is the network IP, the .255 is the broadcast IP, and the numbers .1 through .254 are the host IP addresses. These are the valid or the usable hosts that can be assigned to devices such as computers, routers, switches, printers, and so on. We also know that the /24 subnet mask can be written as its dotted decimal equivalent 255.255.255.0. You may want to memorize this if you haven't done so already. You can always use your subnetting cheat sheet as well to remember that /24 is the equivalent of 255.255.255.0. Okay, so let's visualize this network and assign the IP addresses to the hosts on the network. So here's a network diagram showing a LAN that has been assigned the IP address range of 172.16.38.0/24. So there's our network range. I have already assigned the router interface the IP address 172.16.38.254. This is the last host in the IP range. You will see that the /24 dotted decimal subnet mask is below it. When we configure a router, we have to enter the dotted decimal format of the subnet mask. This tells the router that the size of the network is a /24 network. If we would use a different subnet mask, let's say a /25, then the router knows that only the IP addresses in that smaller /25 subnet exist on the LAN. All devices on the network must have the same subnet mask. So here you can see that I have filled in the subnet mask 255.255.255.0 for every device in the network. Remember that the router IP address, in this case 172.16.38.254, is also called the default gateway for this LAN. All devices on this LAN will need to specify the default gateway in order for traffic to leave the LAN and to be able to be routed outside of the LAN. So you can see here that I have filled in the default gateway for each device on the network. Remember, if you forget to put the default gateway, you forget to configure the default gateway on any of your devices, they won't be able to get out the default gateway. It's kind of like there's a door here. They need that default gateway number in order to be able to reach remote networks such as the internet. Okay, now the last step is to give each device a unique IP address. I will assign laptop 1 at the top the dot 1 IP address. Then the next device, PC1, is going to get dot 2. The next device, dot 3, and then dot 4, dot 5, and finally dot 6. For the printers, right, so for these two printers, I have decided to assign them the dot 100 and the dot 101 IP addresses. You don't have to assign numbers in order. The IP addresses just have to belong to the 172.1638.0/24 network. Just as a side note, we can never assign a device the IP address of .254 because that's the default gateway. Duplicate IPs are not allowed on a LAN. So you would never assign an IP address the same number as its default gateway. That's a big no-no. Okay, where are you going to put all of this information? Let's take a look at this little screenshot that came up here. Let's say we had a Windows PC. So on the Windows PC, you would go to the control panels in the network and sharing tool. And then notice that this window will require you to fill in the IP address, the subnet mask, and the default gateway. So every device on the network needs to be configured with those three pieces of information. An important troubleshooting skill to have is to be able to look at a host IP address and to be able to identify the network in which it belongs. For example, given the host IP address, so a device on the network, that's 10.5.5.6/24, which of the following is its network IP? Is it 172.16.5.0, 10.1.1.0, 192.168.5.0, or 10.5.5.0? Now remember, because we have a /24 network, that tells us that the network bits, or those first three octets, all have to match. So it's probably pretty obvious which one is the network IP. It is the 10.5.5.0/24. So that's the network IP address. Sometimes we call this the resident subnet. So a network IP is also referred to as the resident subnet because this host IP resides in this network. All right, so we're going to work through about 10 problems. Here's our first problem. Given the host IP 10.1.1.5/24, what is the network address? So when you're tackling these problems, the first thing I want you to do is focus on that /24 or whatever the CIDR notation is. So we've got a /24 network. Take a look at your subnetting cheat sheet. A /24 network is one class C. It has 256 total IPs, 254 host IPs. So every /24 network starts with a .0. That's its only starting point for a /24. So the answer has to be the first three, 10.1.1. Those are going to stay the same. And then this is the only choice, .0 for the network. So the answer, given the host IP, 10.1.1.5/24, what's the network address? 10.1.1.0. All right. How about this one? Which subnet does the 172.26.25.119? What subnet does that belong to if it's in the /24? So remember, don't get too worried about that IP address until you go, oh, that's easy. I'm talking about a /24 network, right? /24 network means that you're dealing with 1 pi. So you can take a look that you've got your /24 network. All /24 networks start with 0. So the answer is indeed 172.26.25.0. All right. Here's a little bit different problem. What subnet does host 192.168.4.200/25 belong to? So once again, you're going to start by looking at that /25 and realize, oh, that's right. Check on your subnetting cheat sheet. A /25 is a half of a class C. So if I visualize that, and the other thing you might, just pay attention to, you've got 128 total, 126 host IPs on in each one of those subnets. So, but a /25 is a half of a class C. So remember, we just divide that in half, and you only have a choice of 2 answers. The answer is either going to be the .0 or the .128. What you have to decide is, does the number 200 fall on this half, the .0 half, or on this half, the .128 half? Well, the number 200 is larger than 128. It probably shows up, somewhere over here. So that means that 128 is its network IP. So the answer is 192.168.4.128. That is the subnet in which that IP address, that host IP address ending in .200 belongs. Problem 4. What subnet does the host 172.28.4.102/26 belong to? All right, so we take a look at /26. We look at our cheat sheet, tells us that a /26 is a quarter or a fourth of a class C, that there's 64 total IP addresses. So in this case, I can visualize that by taking my /24 and cutting it into 4 subnets. And because a /26 has a /26 has 64 total IPs. The only possible starting points are 0, because you can always start a network at 0, but then anything that's a multiple of 64. So I add 64 to 0, I get 64. That could be another starting point. Add 64 to 64, that's 128. Add 64 to 128, that's 192. So those are my only starting points. Those are my 4 network numbers. And I have to find out, well, where does 102 fall into place? And indeed, if I take a look, well, 102 is probably going to be somewhere in this range. So the network IP address for my host for the device that has 102 assigned to it, its network IP is 64. So the answer is 172.28.4.64. All right, getting the hang of it? Let's move on. Now we're going to do a /27. Which subnet does the host 10.55.4.17/27 belong to? So once again, take a look at this /27. Look at your cheat sheet. /27 is an eighth of a class C. That means that 1 pi is going to be divided into 8 subnets, or 8 slices, if you will, that has a total of 32 IP addresses. So remember, a /27 has a total of 32 IP. All right. So what that means is that when I'm looking for the subnet, remember the subnet is another word for network. When I'm looking for the subnet, it's going to be a 0 or a multiple of 32, because they have 32 IP addresses in each one of these subnets. So 0, 32, 64, and so forth. I'm looking for 17. I'm looking for that number 17, and I realize that, 17 is going to fall right here at the top. So the answer is going to be 10.55.4.0. That is my resident subnet, or the subnet in which that IP address belongs. All right, problem 6. Which subnet does the host 192.168.36.145/27 belong to? So very, very similar to our last problem. We know that a /27 is an eighth of a class C, or there's going to be 8 subnets, that there's 32 total IP addresses in each. So we bring back that wheel to kind of help us visualize. I'm looking for 145. Where's it going to fall, right? Too big for here, too big for here, too big for here, ooh, too big for here. Oh, wait a minute. I think it's going to fall right in here because it would be, wouldn't quite fit here. The number is going to be between 128 and 160. So it's going to fall in here. So its network number is 128. So the answer is 192.168.36.128 for the subnet. All right. Now, problem number 7, given the host IP 172.25.8.50/28, identify the network IP. So a /28 has 16 slices, a total of 16 IP addresses per subnet. So this is a little overwhelming, isn't it? All of a sudden you're like, what? So remember, we're starting with that /28. We know that /28 has 16 total IPs. So this diagram, this wheel, shows us that these are the only possible network IPs for a /28. A /28 can start at 0, 16, and any multiple of 16. So I add 16 to 32, add 32 to 16, 48, add 48 plus 16, 64. So you can kind of see this is all going in the same direction. We just keep adding 16. What we're looking for is, where does this number, .50, where does that fall in? So we just kind of start looking through all of these subnets, and we can probably guess that, hey, 50 is about right here, right? 50 is going to fall in there. So the answer is going to be 172.25.8.48. So .48 is the network IP for that device that was given the IP address and the subnet mask of 172.25.8.50/28. All right. Now, problem 8, we're actually going to look at 3 different methods, because when we get all of those IP addresses on there and so many different subnets, that's kind of hard to draw out that pie with so many slices every time. So we're going to take a look at some different ways to do this. So given the host IP 10.20.1.185, there's our number, 185/28. Identify the network IP. So a /28 is going to, as we know before in our last example, is 16 slices of pie, or 16 subnets with 16 total IPs each. So method 1, we could just start out, we know that all of the IP addresses are going to start with 10.200.1. So the first 3 numbers are all the same, so we don't have to worry about those. So I could start at the beginning and say, oh, there's 0, add 16, add 16, add 16. I don't have to even do it in the wheel. I could just keep adding on there and just keep going until I find a number that's close to 185, where I see where 185 fits in. But that's going to take way too long to have to figure that out. So that's not the most efficient way to figure out this problem. So what we can do is take a look at method 2. So method number 2, we know for sure that if we had our /24 and we just divided it into 2 parts, let's say .0 and .128. So this is the starting point for a /25 and anything smaller. So /28 is going to be the starting point for a /25, 26, 27, 28, 29, and a 30. All of those networks can start with 128. So since we know that 128 is closer to 185, what we can do then is start with, so here we're going to start with 128 and just add 16 to it. So instead of having to start with 0, I'll start with 128 because it's on the second half, and then I'll just add 16 to get 144, and then add another 16, 160, add another 16, 176, and add another 16, 192. When I do that, I can say, hey, I'm looking for where 185 fits in. It's not going to go beyond 192. So it's actually going to fit right in here where the network IP would be 176. So I could do the same thing as method 1, but just start further into our subnetting wheel so I don't have to do so much math. So that's another method, is just starting at a closer point to what you're looking for. Now, the third method is a little bit different. So method 3 works like this. You're going to start with the host IP 10.200.1.85, which is right here. And we already established that a /28 is equal to 16 total IPs per subnet. So what you do is you take this 185, so I'm taking that 185, I'm dividing it by 16, and I get the result of 11.5.625. So what we do is we don't really care anything about the remainder, so we just scratch that out. And then I take 11 times the number of total IPs, and I get the network IP of 176. So this 11 shows me or tells me that that is the subnet would be numbered. If we counted all of them, that would be the subnet that's numbered 11. The other thing you can do is, so we've identified that 176 is the correct answer. That's our network IP. But if we needed to, we could also take a look at that overwhelming subnet wheel and go, you know what, now that I look at this and I've looked at how we've found it, indeed, that .185 does fall right here. So 176 is the network IP address as well. So you can always come back and kind of visualize what that looks like as well. Okay. Problem 9. What is the resident subnet of the host IP 10.3.67.102/28? So remember, /28, that's 16 class Cs, 16 total IPs. So what we're going to do is we're going to jump right to method 3, where we started with the host IP. So there's the host IP. We know that a /28 is equal to 16 total IPs per subnet. We got that off the subnetting cheat sheet. And so we're taking this 102, dividing it by 16, and coming up with 6.375. We don't care about that. Remainder. So we're just focused on the whole number of 6. We take 6 times 16, and 96 is where our answer is going to be. Right? And let me just get rid of this. So if I take a look on my subnetting wheel, I'm looking for 102. Now remember, we always start counting with 0, so this would be 0, 1, 2, 3, 4, 5, 6. Indeed. So this subnet with IP of 96, that is the answer. That's where we're going to find that number of .102. All right. So there's the answer, 10.3.67.96. That is the resident subnet of the host 10.3.67.102. Okay, the last problem that we're going to, or maybe it's the next to the last problem that we're going to do, and then we're going to do some on our own. So what is the resident subnet of the host IP 172.19.4.58/29? Okay, so /29, they're getting smaller and smaller. A /29 would be like taking that one pie and making 32 little pieces out of it, and 8 IP addresses per subnet. So we're just going to go right to that method 3, where we start with the IP address. We know that a /29 is has 8 total IP addresses per subnet. We can get that right off the cheat sheet. That information's there for us. And then I'm just going to take this number, 58, and divide it by 8 total IPs and get 7.25. And so I basically just say, okay, 7 times the number of 8 total IPs. So the address of the network IP is going to be 56. So that is the correct answer for that particular problem. All right. So this IP address, if that's a host IP, right? That belongs to a device. What's its network IP? What's the resident subnet? Where does it belong? It belongs to the range of IPs that starts with .56. 172.19.4.56 is the network IP, and then all of the addresses below it are all part of the /29 network. Okay. From 11. All right, this is the /30. So that's going to be the last ones that we learn about, the /30 subnet. What is the resident subnet of the host 10.8.1.241/30? So once again, a /30 is be like taking that whole pie and cutting it into 64 little slices. So only 4 IP addresses, total IP addresses in each network. That's too much to actually draw out. So we definitely want to go straight to our method 3, where we write down the host IP. We know that a /30 is 4 total IPs per subnet. We take the 241. We take the 241 divided by 4 is 60.25. Forget about that remainder, and then just take the 60 and multiply that by 4, and the network IP will start with .240. That's our starting point for that range. So that would be the answer. Okay. Now, when we take a look at that, that .240 is the network IP. So something I want to kind of think about is that remember that the answer would be 10.8.1.240.30. That means the whole IP, the whole network would be 10.8.1.240, 10.8.1.241, 10.8.1.242, and 10.8.1.243. Remember, this is my network. This is my broadcast. So these would only be the 2 usable hosts that I could assign in that network. And remember, the /30 is the perfect, right? The perfect subnet for a point-to-point network where we have maybe router 1 and that's connected to router 2, and one of the interfaces here could belong to or could be assigned the IP address of 241, and the other one could be assigned 242. All right. Okay, good work. Here we go. Now, you are going to do this on your own. What I want you to do is identify the resident subnet of the following host IPs. So go ahead, pause the video, and when you return, I will reveal the answers. Good luck. Okay, so I am going to reveal the answers to you. Here we go. 10.40.67.0, 172.30.1.64, 10.1.1.12, 192.168.1.224, 10.66.109.128, 172.16.1.4, 10.116.3.0, 10.40.67.80. Now remember, because these are network numbers, typically we always follow the network number and we identify the subnet mask after the network number. So typically the CIDR notation is going to always be printed after that network number. All right. Congratulations, you finished subnetting level 10. Impressive.